Good day everyone and welcome again to my YouTube channel. In this video lesson, we are going to have another proof for the alternative segment theorem. So in this proof, we are going to have this case, okay? So we call this case number 2. So we are going to construct angles that are the same arc, or we are going to have an angle and a chord that are not at the same semicircle. So we are also going to have a semicircle. Alright, so let's begin. Alright, so we have now a very beautiful blank page. So here are now the elements of our proof. So first, we are going to have a circle. Okay, and then we are going to have a diameter. Let's have a diameter. Right, so we are going to make use of point C as the point of contact for the tangent line. So we are going to create a tangent line. So again, a tangent line is a line that touches the circle at one point. So we have tangents, and then click on point C and the circle. And now we are going to create an angle at the alternate segment, and to have that, we need we need to have a chord first. So we are going to connect B and C, and then we are going now to have the angle at the alternate segment using vertex D. So we are now going to connect D and C, and then D and B. Okay, so as you can see, the chord is at the right semicircle, and then the angle of the alternate segment is at the left semicircle. Alright, so I think we have all of the elements now. So let's prove, okay, that the angle formed with chord CB and tangent line CE are indeed, so that would be angle BCE. It should be, we're going to prove that it's equal to the angle at the alternate segment. And the angle at the alternate segment is CDB. Okay, so we are now going to measure. Okay, so angle BCE is 45 degrees. So let's change that. Let's move B here. Okay, so we are going to assign a variable to angle BCE because it could be any angle or any measurement of an angle. So we are going to call it angle X. Okay. So what is now the measure of angle ACB? We all know that the angle formed with the line that passes through the point of contact and the tangent line is equal to 90 degrees. Again, let's define some terms. So when we say point of contact, it is the point where the circle meets the tangent line. And then we are going to have radius AC, or line AC, okay, that passes through the point of contact, and always that radius or that line that passes through the point of contact will be perpendicular to the tangent line. So we're expecting that angle ACE will be 90 degrees. Okay, and then we are now going to measure angle CB. And we all know that ACE is 90, so angle ACB will be 90 minus x. Okay, so we are making use of algebraic expressions. Okay, and since x is 45, then we can say that ACB is also 45 degrees. Alright, so let's add some colors. Alright, so we have some colors here. Let's add another element for the proof. So we are going to have point F, and then we are going to join point F to point B. So again, we now have angle CFB, and such angle is at the same segment with angle CDB. Again, angle CDB and angle CFB are of the same segment. Okay. Now we have a triangle CFB, and then with an angle 90 minus x. But what can you say about the angle CBF? It's an angle at the semicircle, right? So we'll be expecting that angle FBC will be 90 degrees. So let's confirm that. See, it's 90 degrees. Okay, so what is now the measurement of angle CFB? So we are going to make use of the property of the triangle. The sum of all interior angles of a triangle is 180 degrees. Alright, so we're going to make use of that property. So we're gonna sum up all of the angles of triangle CFB. So we have 180 degrees minus 90 minus x. Okay, you have 90 minus x, then plus 90, and then let's call angle CFB as angle Y. Okay, so again, 90 minus x plus 90 plus y is equal to 180 degrees. And then we add up 90 plus 90, it's 180 degrees. And then we have a positive 90 at the left, and then we have a positive 180 at the left, and we have positive 180 at the right. So these two will be cancelled out. So, and then we transpose negative x from right to left. So we now have x equal to y. Beautiful, right? So we can say then that angle CFB is equal to x. So we are going to just change y to variable x. Okay, and what's the measurement of x? It's 45 degrees. So let's see. So if we're going to measure that, indeed it's 45 degrees. And what's the relationship between angle CGB and angle CFB? Yes, they are angles at the same segment. And again, angles at the same segment, look at this. So we are going to make use of this property wherein angles in the same segment are equal. So this is CFB is 45 degrees, so CGB will also be 45 degrees. Alright, so we just have proven, okay, that the angle formed with the chord CB and the tangent line CE, that's 45 degrees, is equal to the angle at the alternate segment. So let's appreciate this GeoGebra build thanks to 2We Tech. Okay, so we have a segment, okay, the alternate segment, and then we have here the angle BAQ, right, is the angle formed between the chord and the tangent line. Okay, so what is OAQ? So we're going to create angle OAQ. So again, the angle OAQ is formed between the radius, with the radius and the tangent line. And we know that the tangent line will always be equal. Alright, so sorry for a little confusion there. So again, angle OAQ, okay, is formed between the radius OA and the tangent line AQ. And the tangent line will always be perpendicular with the radius. So the measurement of OAQ is 90 degrees. And then we have now BAQ. Alright, so that is the significant angle. Okay, that is part of our proof. And it's the lower part of the right angle, right? So we can say that its measure is 90 minus OAB. This one, OAB. Okay, the orange angle here. Alright, and then we now going to have a diameter from A, and then add another element connecting D and B. And in that process, in that step, we now have angle ABD, and that angle is an angle in a semicircle. Okay, so that measures 90 degrees. Now angle ADB, okay, ADB is equal to 90 degrees minus DAB, the orange one. Okay, and the sum of, we're considering that the sum of interior angles for a triangle is 180 degrees. So we have visually shown and algebraically shown that angle BAQ is equal to angle ADB. Okay, and we're going to add another element, a point C here, and it's another angle at the same segment, and basically this is the angle, okay, at the alternate angle, right, to angle BAQ, or it's an angle of the alternate segment considering chord AB. Okay, so we all know that angles at the same segment are equal, so we can definitely say that angle ACB, okay, an angle at the alternate segment, okay, when we have a chord AB, is equal to the angle formed with chord AB and tangent line AQ. So thank you so much for watching until the end, and I'm going to have another sub-case, okay, for case number 2. So please stay tuned. Thanks again for watching. I hope this helps. Bye!